Okay, we can get started now. So welcome to our last day of workshops. Right now we're going to be having a talk from Skeletor from Yearn about build and profit from Yearn Vaults. He could take it away now. Thank you all for joining us.
Hey guys, thank you for the introduction. Okay, as the presenter said, we are going to go through a few examples of how can you build on top of Yearn V2 vaults. So Yearn V2 vaults, as you know, are like the current vaults that we have. Right now, they are not a part of the new EIP, obviously. The EIP 4626, that is for yield tokens. What we're going to do here is go through some examples of how to wrap a V2 vault for it to be compliant with the new standard, and how you can build on top of that or use that to integrate with different type of integrations that you might like or build, so you can get some profit out of that. This profit being fees, etc. And also as for Yearn, if you basically route funds through us, you can enter into a, let's say, a B2B system where you can get kickback out of the funds you deposit or your users deposit through your protocol. Okay, so let's start. So basically, not sure how familiar you guys with the V2 code, but basically what it does, it takes a token. So this can be, let's say, DAI. So users can deposit DAI into the vault. The vault will issue some shares for them, depending on the current price per share. Those shares are also an ERC20 token. Users that have these shares can later redeem those shares. If their price per share increases, so the vault is profitable, the amount of underlying, or in this case, DAI, that they will get out of that will be higher. So basically, this is what we count as APY. So this is a simple wrapper. Actually, most of the code is inside the vault code base. This is a separate contract from the vault. So whenever you initialize it, you need to pass an argument saying, okay, which vault are you wrapping? Then it grabs automatically in the constructor it sets the name and symbol, because the EIP for 626 requires the yield token to also be an ERC20. So here's a difference. I'm not sure if any of you watched the previous workshop, but in the previous one, we had a wrapper that was not actually issuing new shares on top of this. So we'll go into detail a little bit later about this. But the thing is, this wrapper will hold the vault shares and issue like a copy of new shares to the depositor or the user of this wrapper. So yeah, it's pretty simple. You initialize with a certain vault that cannot be changed, obviously, and then you have some like utility functions, basically to see what's the total supply. So this is basically your shares token. Like all these, as he says, is ERC20 like token compatibility. And here comes the fun part. So whenever a user wants to deposit into your wrapper, obviously it will need to approve the underlying token, in this case, DAI. So what we would call here, we have like two separate functions for everything. So basically, when you call deposit, you are like working with the underlying asset. So in this case, DAI. So this would be like 100 DAI or something like that. But if you call mint, which is also like a kind of deposit type of function, but you're working with shares. So you can say, okay, give me 100 shares. I don't care how much DAI you drain from my allowance. I want 100 shares. Both of those functions use the same like internal function, but obviously the mint function just checks, okay, if you want 100 shares, how much assets would you need? So if we go to this deposit function here, it's like almost at the bottom of the file. We can see that it receives an amount, obviously, like 100 DAI, the receiver, that can be another account, so it doesn't have to be the message sender, and the depositor that is the message sender. So this is where we are going to be taking the tokens from. So here we save some stuff to memory just to save some gas. We check if the allowance to the vault is correct. So because obviously we need the vault to be able to also drain tokens from us. This can be done here, which is basically we are making the first depositor pay for this allowance assignation into the vault. But yeah, this can also be done in Constructor or in any other place. So the first thing we do is we take the tokens away from the depositor into this wrapper contract, obviously the amount that the user required. We check the allowance on of the vault as well. Oh, sorry. Okay, this is I messed up. Okay, this is the approval, and this is just to know if because you can pass like the max amount. So if you send, okay, I want to deposit everything I have, you need to check if everything you have is either the amount of your balance of the token or the max amount of the allowance, because a user might have 1,000,000 DAI but only allowed 100 to be spent, so we will take the allowance, so 100. Or if you have max allowance but you only have 100 tokens, obviously we won't try to deposit all your allowance. We'll deposit the amount, the balance you have. Sorry for that. So then we just transfer the tokens. This is where the first depositor pays for the approval into the vault. And here comes like the interaction with the underlying vault code. So since the vault deposit doesn't necessarily take the entire amount you are depositing, because it can, so the vault has a max amount of tokens that it can take. So let's say it depends on the current depth the vault or the current assets the vault can take. This is kind of a security measurement we do at Yearn. So not all vaults can take infinite amount of money. We constantly bump the amount of those. But let's say a user wants to deposit, I don't know, a crazy amount of money. The vault might not be able to take all the amount that it wants to deposit, but might want to take some of that. So we need to check how much it actually took. For V2 vaults, the only way, sadly, to do this is check the before and after balance. Like we check how much balance of token we had. With deposit, we check how much balance of token we had. We have after that, and then we know how much it actually used. So and also it returns them into shares. So this is easier. Okay, these shares that have been minted from the vault are now being held in this contract, so in the wrapper. This is like a big difference with the other presentation we did a few weeks ago. Here you can also avoid doing this and just send the shares back to the depositor. So you can just use this wrapper as a router. And obviously this won't be like fully ERC 4626 compatible because you are not behaving as an ERC20. But yeah, who cares? Whatever is easier for you. Yeah, in that way also users can take the shares out of that and do other stuff. But obviously accounting becomes a little bit harder for you as an integrator because you don't know which shares actually came from your protocol. This way, all the shares that all the users that deposited through your protocol, you know, because you have the shares in this wrapper contract. So it's easier also for you to do the accounting. So yeah, then we check how much was deposited. This is useful here because we will refund you all the tokens we didn't use in the deposit. So let's say you sent 100, but only was able to take 10. So we will refund you 90 tokens. And then we mint the new shares. So these new shares are actually the vault wrapper shares, which if you remember here, we assigned like the name for the ERC20. So those will be like, you know, YDAI 4626 tokens. to the receiver. So this can be either the message sender or somebody that the message sender was assigning as the receiver of the new minted shares. And that's it. So then if we go back to the top, so we went through deposit mint, and so withdrawal and redeem is the same basically. So on withdrawal, you say, hey, I want X amount of DAI, and on redeem is, hey, I want to redeem X amount of shares. So the withdraw here basically takes the asset, so 100 DAI, who will be receiving, who will be receiving those DAI, and who is going to pay for that. And on redeem is the same. The only difference is that we had to call first preview redeem to know how much underlying assets those shares that the user is trying to redeem actually are worth. Then we go to withdrawal here at the bottom right below deposit, and it's practically the same. So we check actually how much available shares the vault can actually basically burn. Yes, this repo is public. I will share the link afterwards. Yeah. So it's either like the minimum, so the amount of shares the user has, or the max amount of shares the vault can take. So here's a cool thing, which is, if you remember, this wrapper has also its own shares. So right now we are redeeming these shares. So this is why this dot balance off, because obviously this contract is behaving as an ERC20. But the thing is, the shares that this contract has are like 1-to-1 with the underlying vault shares. So we actually know that one like vault wrapper share equals one vault share. So we can check. So there are two things that are fun here. We don't need to have permission for the user to use these shares because it's like in the same contract. And also, we can map it 1-to-1 with the underlying shares. So we don't need to do like approvals for the user to be able to route the shares through us. So we, as the token, you remember on deposit, we need to basically take the tokens away from the user and then approve them into the vault and then blah, blah, blah. So here we don't need that. We just like, boom, use the shares because we already have them here. And obviously on the vault, it's the same. The vault doesn't require you to like approve the vaults to itself because it's already the same ERC20 contract. So we check if there are some shares available to be redeemed. The vault might not have funds available, so this is also why we need to check this. And then we kind of estimate. So this is kind of a back and forth because now here we have the amount, and here we need to send it back to the amount of shares that we can take from that amount, or that amount, how much shares is it actually worth. So this is why we're using the price per share now. So let's say price per share is 2. So we are trying to redeem 200 DAI. So basically we are going to try to be redeeming 100 shares because 1 share equals 2 DAI. Obviously, if the vault was profitable, if the vault is not profitable and the price per share is 0.5, then 200 DAI are worth 400 vault shares. And then we do kind of similarly, we check on withdrawal as well. We need to check how much of the vault shares were actually used because the withdrawal function. So you say, hey, I want like to burn this much shares or as this much shares, but sometimes the vault will say, okay, I will burn 50 out of the 100 you try to because I don't have any more basically funds to pull from. So I'm not going to give you, let's say, 100 DAI and burn all your shares. I'm going to like just burn you the ones that are worth 100 DAI, the ones that you used. And this obviously as well, we only burn the amount of burned shares actually from the user. This is the current vault wrapper. And if we have any unused shares, we send them back yeah, to the user. So yeah, that's practically it. So a few cool things you can build on top here is basically you can add either fees on depositing or on withdrawing for your users. You can also do some cool stuff that we have as examples here. I will try to quickly go through. So this is the Sugar Y Vault. Basically, here you can deposit your vouchers or your tokens, and you can assign a recipient for the difference in the yield that those shares are going to be generating. So whenever you start sharing the yield, you set up a receiver and an amount. So this can be, I don't know, your Netflix or whatever service you might want to pay, if obviously they support, or a friend or you know, a loan receiver that you're trying to repay out of the yield of your tokens. And here, well, we do some checks. You transfer the underlying amount. You set all the balances and stuff afterwards. Just like take into account that this has not been audited. And here we can see an issue. So this line, as you remember, whenever we deposit into the vault, we are not sure that the vault will actually take the entire amount we are sending. So the amount we are basically taking away from the user here might not correspond to the amount of shares the vault is giving us back. So here you might see that the amount is 100 DAI, but the shares are not equal to 100 DAI worth of shares because the vault could only take a half of that. So basically, you're robbing the users out of half of their deposited underlying. This is the same when we do claim yield. So on withdrawal, it's a similar situation. So this is also something that you need to take into account when interacting with V2 vaults, and also when interacting with any underlying protocol. You need to properly check the code to see like what's going on under the hood, just that so you don't bubble up issues back to your users. So yeah, here you set up like all the different variables that that are needed for the accounting. You can also call stop sharing yield if you don't want to give free money to people anymore. And any donation recipient or user, let's say your friend or whoever, can call this function saying, hey, this would be you. So your friend will be saying, hey, claim yield from my good friend that is giving me money. And it will check the shares. It will check here. So basically, let's say when we did the accounting, we said, okay, we deposited 100 shares. These 100 shares were worth 100 DAI. But right now, those 100 shares are worth 200 DAI. So we check the difference of those balances, how much shares are worth actually. So we say, okay, then you as a good friend will only get, so your remaining shares will be half, because those are the ones that are worth the amount of DAI you actually deposited. And the remaining shares or the remaining DAI, so the extra 100 DAI that was generated through APY, will be converted back into shares and will be sent to your friend. Yeah, I think, oh no, yeah, maybe it will, let me check. Yeah, I think it will just send the tokens back, but you can share as well. You can send the vault shares as well, so that your friend also keeps on getting yield out of the claim he just did. If not, he will just get the underlying token and it would be it, but it's okay. Either way, should be good. Unclaimable basically has the similar logic from what is inside here, the checks like before and after balances of how much those shares are worth, and it will return you the amount of those shares converted to assets. So how much DAI can you claim out of that? Obviously, this only works for vaults that are profitable. If the vault you are using or the yield token you're using has a negative APY, obviously your friend will never be able to claim anything because you just give them give them some lossy tokens. And then, yeah, we have some utility functions to be able to convert back and forth from tokens to shares. So yeah, that's it. Maybe let me check if there is something else that might be good to explain here. But yeah, that's it. I think. Does any one of you have any questions? Let me try to get the repo. So
yeah, if anyone has any questions, just post them in the Zoom chat below.
So this is a Foundry repo. This is the link for it. So Storm is a Yearn contributor. This is the White Starter Foundry kit. We also have a repo someone did on Hardhat for this thing. So this is an external contributor. It's also under the Storm name. We will eventually migrate this back. So migrate this into the Yearn organization. But obviously, as you see, we have some these contracts are like examples, so they are a bit buggy. So we don't want to introduce them into our org. So yeah, you can use this to yield rewards. I think this what you're saying is okay, mistype. Okay, but I think I understand. Yeah, you can basically use this for any underlying that we support in a vault, and you can basically have that underlying be a yield, convert that into a yield token. Yes, you can. Yeah, you can use this to share the yield rewards. You can also use this. Let's say you have a ton of funds that are not being used right now. You can deposit them into Yearn, into a positive APY vault, and you can get some APY on that while still like getting your underlying available if you need that for your users. Yeah, you can also build UI integrations on this. So basically, you can route users to deposit through here because I know you're providing gas savings because what you're doing is you're like getting all basically the funds into a pool and then depositing all them as one. So you're getting the funds in a separate chain and then you're reaching them, depositing them, and bridging them back to your users. And then obviously you can get a cut out of that either through like the difference between the PPS, so the yield when the user deposits and when the user withdraws, or just like flat deposit or withdrawal fees, either in shares or in underlying. You can also do some fun things, which is, yeah, no problem. You can create a separate token that represents the yield, because I know at all times what's the difference between those. So you can also create a separate ERC20 that is the difference between the previous PPS value and the current PPS value. And you can also start like a betting market on how much APY would that get. There are protocols already doing this, but also you can. So PPS value is price per share value. This is what we have. Let me check, where was this? So here, the vault has this price per share. So it indicates how much one share is worth. So let's say this is expressed in like the same decimals as the underlying asset. So in the case of DAI would be 18 decimals. So it will say, okay, one DAI is worth X amount of shares, or one share is worth X amount of DAI, basically. So this might be, I don't know, 1.1. So basically what this says is that one share is equals to 1.1 DAI. So whenever you want to either mint one share, you need to provide 1.1 DAI, or if you have one share, you can redeem it for 1.1 DAI. Obviously, this will hopefully be always an increasing value. So this will go 1.1, 1.2, 1.3, etc., etc. So this is 1.4 would be like a 40% increase in your token value, because now this is 1.4 DAI. So if you deposited when the PPS value was 1.1, which was a 10% value out of the underlying token, and then you are withdrawing at 40%, you basically made 0.3 worth of DAI. Yes, exactly. Yeah. Yeah, if you deposited when the price, so the question was the yield would be at 1.4 would be 0.4. Depends when you deposited, obviously, because whenever you enter the market is how much you paid for those shares. So if you paid 1.1 DAI for one share, obviously, if you deposited one, yeah, exactly. So this is why you need to calculate the difference when you deposit and when you withdraw, and this is why here on deposit we have all this accounting to know like how much tokens you actually paid for this amount of shares. Yeah.
Great. Is there any more questions? Doesn't look like it. Yeah, I think we're good. If anyone has any more questions, you could bring them over to the Discord channel. We have a Yearn sponsor channel where you can post all your questions there. Thank you very much, Skeletor. Thank you everyone for joining us today. We do have another workshop starting in 30 minutes with MakerDAO on how MakerDAO keeps building on DAI. So please tune into that and bring all the questions over to Discord if you have any. Thanks all for joining us.
Thank you so much. Have a good day.